Okay, so I hope everybody can see my screen.
Yes.
So good, thank you. So I have just three very short questions that I'd like to go through with you about yesterday's material. Here's a question. So a car starts to move going north and it's speeding up. Its speed is increasing. So what is the direction of the acceleration, first of all? And secondly, what is the direction of the force on the car? So let me give you a minute just to think about this, talk to your friend next to you, and then I'll go through the answers.
단들 디랑아서 저 가시지 당기 인수와 저한테 다 계산그 감선다 저어주에 다 단단되게 저 때나라야 아니 랑코시 장장쇼라야 장쇼라야 아니 구초타야 고추데티 아니 진조 솔루션요레스 와 스피드는 업 진조 솔루션요레스 조스투고요레스 아니 티값스 아니 그런 게 일는 거 가쇼가레레스 아니 티강라야 아니 랑코게 땅라 포피기 슈크 가쇼가레레스 네텔레제서 카마 치스테기 인스체소게 아니 수수 드로탄 냠테 트리드나로나스
Okay, so the important thing here is that the acceleration is the change in velocity over time. And so there are two parts to this. One is there a change in the speed? And the other is there a change in the direction? So if the car is moving north and it keeps on moving north, the acceleration could either point to the north or to the south, depending on how the speed is changing. So in this case, the speed is increasing. So there's a positive change in velocity towards the north. So the acceleration is also towards the north. And then Newton's second law says quite simply that the acceleration is the same thing as the force per unit mass of the car. So the acceleration of the force will always point in the same direction. So if the acceleration is towards the north, then so is the force.
단단데 값에 니고지가레요레세나 단데 값에 세야지 뉴체스 보러 뉴체티 안에 고 가서 단 드레든 고초탄에 장소난 고초탄 거레서 그래서 단단데 값은 가수고 뉴노가 개체시면 담발아야 뉴체긴 지로아 개체시 그래서 뉴체긴 지로아 단 뉴체티 디 값이 진조라 두고 두서도 와스 진조라 두이 값이 아니 뉴체티 값이 고 조체티 진조가 두비게 등라야 아니 거기에 디가사 아니 카쇼지요로 카쇼데 단다에 반에 상쇼라 두고 두서도 상쇼라로 상쇼라 다 디갑텔라야 아니 델라 테니 중위기 뉴노가 카쇼카레세나 뉴노가 카쇼데 지진에 장탄 진에 토로다 탄도 올라 마시 돼요 마레스 로티 값에 아니 단다게 니갑텔라야 아니 그 진조스 두고 예장 진조스 두고 예장 아니 뉴노 가쇼데 텔라테데 요레스 로 장쇼라 텐데 요레스 다 뉴노게 가쇼데 장쇼라 텐데 예나 네 값스 아니 콜라 포피기 슈게 가쇼데 가레스 슈게 가쇼데 가레스 다 슈게 가쇼데 가레라나 디 가서 뉴트론 게 텐치 니바게 시샤 반바나 뉴트론 게 텐치 니바 가서 그래서나 고 슈티 가서 슈 텔라텐데 가서 뉴노 체크 요르와 인스탄발라야 슈탄 뉴노 거 가서 지총레스 고레스 인스탄바 디 값스 슈크 가서야 디 장쇼라테 요레스.
Okay, I'm sorry. I should keep my sentences shorter. Very good. Okay, so that was the first question. Second question is related to the first one. So a car is moving forward towards the north again, but this time it's slowing down. So what is the direction of the acceleration, and what is the direction of the force on the car again? And we'll take a minute. I suspect that you'll find it easier to answer this one, the first question.
That twenty Batikare any contents on Lancorchi any Chanshola young Guchuchi is right. And a Guchucho don't any cheated the chimbares, tettle chimbares, cheated son yoris. This Tambalaya, T. Captilaya, ne Nunongo Kashokares. And a T. Ganlaya, and a Lancorgi Tangla Poppy, Shuka Kashokares. But Dortin Chayens, Chesu, young Nankula Karmachik Nala, to the Namuchis. Niroi by night and the gangi to a Telangatsuki Sarwa, Tila Trinity, and the draw one de la land at this little yes.
Okay, so probably as you realize, the only difference with the first question is that now the car is slowing down instead of speeding up. So the acceleration, the change in velocity now points in the direction opposite to the velocity.
Hata de Capsi Chesuge, Tunonchomati, Gangi, Toatan, Denchak, Shepherd to the Caresena, the Lancorti Chital to do Segdus, that to yoris, Chital to yoris. That is Tamalaya de Capsu, and Eco Chital to your paina, taking Yonongo Kashoka Sena, Yonongo Kashote, and a Kugi, Nursega Kashoton Dogares, Toshosiores.
So the velocity points towards the north. That's the direction in which the car is going. And therefore, the acceleration points towards the south. And again, because the force and the acceleration always point in the same direction, the force also points towards the south.
That dig observe Tandangatsuge Jokset Segurata, Tanda de Capsuke, and your take a cashote, Shanlate de Roymbana, Yonongo Chita do your son, Yonongo cashote, and it Hulate de Resra. Tenan Shingi, and also Yonon town, this Jabajini shooting check a cashote cartoon by an Astupa in Guzan, the Capsu Shuku cashote cote, Resina, Shuku cashotea, Thusolate de Res.
Okay, here's another question. So now we're looking at a ball. It's very similar to the situation we discussed yesterday. There's a ball, it's thrown upwards, and gradually it slows down until it stops before coming down again. And it stops just for a very, very brief instant.
Tadi 계속 가서 이제 시작하나신데 다 좋아들 답변은 가서 폴로지야 이거레스 폴로지야 여쇼라야 강쇼라 유피캅스 고야 유피캅스 아니 지다 도데데 아니 고 제모네와 찔레피캅스 추스고 다 응고쇼 메피네와라 추스지네와 단테네 양체만 코레 니사용고요레스와 아니 디캅스 제충이 고에테 폴로테 고 감네 then gumege nikola nig research borwa otika tika resena hachanta duyun hachon tonton chikena la ya otus nigyo pangi gures.
And I'll give you three choices, and then we'll see afterwards by show of hands what the choices do you think are the best choices. So the question is, what is the direction of the ball's acceleration? So choice number one would be upwards. Choice number two, there is no acceleration. The acceleration is zero. And choice number three, the acceleration points downwards. Okay, so which of those three choices do you think is the right one? I'll give you a minute.
Tanda de kapse joate karesana ane koge polote ya stela lepi kapse ane nyunong khaso karere swa ane ngechula damka sumtegi inswa damka tambote karesana nyunong khaso te ya chusdiores ya tangsula ya chudores damka nyoate nyuno yo mares sumba de la ya ane khama chudores wa shula chudores ane te lapa chanchi dus tagiens ane te la kamachi kiren la ya ne pridanologis.
Okay, so let's see. The choice number one is the acceleration points upwards. By show of hands, how many people think the acceleration points upwards?
Damka tampote ane de kapse nyuno khaya chode. Nyuno khaya chode re sami suyes.
Okay.
Look like nobody think the
Look like
acceleration.
nobody, yeah. My picture is really tiny, but it looks like nobody thinks the acceleration points up. It's good. Okay, who thinks the acceleration is zero at the top?
Jimotela lepi kapse nyuno lekore sami suyes.
There are two.
Two people. Okay, all right. Okay. I guess, but let's do it anyway. How many people think that the acceleration points downwards?
Nyuno de khama chode sami suyes.
Yeah, okay, so I'm seeing a lot more hands going up. So that is actually the right answer. Although the people who thought that the acceleration would be zero, that's an interesting answer as well. because it's not unreasonable to think that the acceleration is zero. So yeah, I'll let you translate that and then we'll go through it.
Nyurnon ge kasho ma chodo yore se din digbares ne na mi kashi chike yang go karsure nyurnon le ko re se ge tinda do chiang tu stati anga kala tese jagi yen se tinda do chi gomba imba na yang goya la yang ko jinsen yang tantan chi yores.
It's common to think of the velocity instead of the acceleration. So at the top, the velocity is indeed zero, but not the acceleration, because we have to remember that the acceleration is the way the velocity is changing, not the velocity itself, but how it's changing. So there, I'll let you talk about that.
Da tanda di nikabla ya chichina tanda gi ti kapse nyurnon ti lekore kon tambala ya nyurnon se ti nyursela ya samu tangse batena dochi res doa tanda di kapse ane polo ti ko ya ipi kapse simula lepi kapse ko nyursela lekore na nyursete lekor tante res nyurse lekor chago res lekor res imbai na ya nyurnon sibi kapse nyurnon ti nyurse ma res Nyunoti karele na nyursegin jirwa seguyores nyursegin jirwa din stambalaya nyurse leko chago yore cha yores imbana nyursegin jirwa de kapsu leko chago yomares.
Now there are two ways to answer this question, or to think of the answer to this question. One way is to think about what is happening to the velocity. The acceleration is a change in velocity as the ball goes up. The ball is slowing down, and then it stops and then changes direction and speeds up going down again. So the change in the velocity is downwards, even at the top. The other way to think of this is to think about the force. The force is acting on the ball is the force of gravity. And gravity always pulls down towards the center of the earth. So, and by Newton's second law, the acceleration is in the same direction as the force. So again, the acceleration must point downwards.
Tanda de la ya churange samlu tambi kapsirwa samlu tanya de chigtela ya deshe jaga chigro land de la deshe jaga ge ching deshe jata ma sona ni yores ni la samla tana de kores ta tampote kare samla tana de kores na nga so puluti ya you pickups ane yan ru stambala ya ku chita do yoro ma ni stimula le tigil ma yon stambala ya jinjo do yoro din stambala ya ko ge niba ganzala samlu tamba imbaina ko nikap kancha ge kapsa puluti ge gangla ya nyinonti kha ma chodo res kachna nyinonti kha ma cho yeja ya rubi kapsa chita ta ma yon bi kapsa jinjo do res ro data kalana simuti la happy kapsa te chabgo res ta nipa te samna tamba imbaina nga chu neutron ge tension nipa ko la samna tamba imbaina neutron ge tension nipa te ge karse go res na nga chu gi shu ta nyino ni ge khasho ka ti na shipa inse go ro de mare tin stambala ya skula gi tension te ge ni polo te gan la ya ka tu imbaina popo ro tin stambala ya polo te yan do ta ma yon we ni ka ta mala ya skula ge tension te ge ma thengi yo so nyino te ka ti imbaina kha ma cho de res.
Okay, good. So, so much for those questions. So before we continue, I just want to review very quickly what we learned yesterday. So first of all, a force causes an object to accelerate. There's a cause and effect relationship here. And to accelerate means its velocity to change.
Danga suge kesange zada tujitu kola ya jarjonchi chigi insrwa 당보티 가르에서나 슈키 뉴보치라야 뉴노 존도 지고요레 스타텔라야 가츠고 주탄 드리버스고라다 주탄 드리버게 니탄치요레 스타티 가르스고스나 슈티라 테네데테 아니 뉴논 티스체고요레 사티고요레스 타 뉴논 사티 티기 과 카르랑고요레스나 뉴보티기 뉴살란도아 뉴살란 조란도아테 고요레스
And again, any change in the velocity is an acceleration. The object can be speeding up, it can be slowing down, that would be a change in the speed, or it can be changing direction, it can be turning. So that would be a change in direction, that is also an acceleration. So a force will cause an acceleration.
tanda di kapsa nga suge nyurna saya chorwa nyurna saya ti tanda nyurna di kapsa kwa la ti nyurse la ya jro do ya chorwa tela ko go yorwa estambala ya nga su shu chi kin nyurna che kresta nyurna che ya ti kapsa nyurse la jro do ta tela ya ko nyurse ti jinjo do na de yore jita do na de yore en shenda chi la ya ni nyurse ga khasho tela jro do na en de yores.
And I should mention here that when I say a force, if several forces are acting on the same object because it's interacting with different things, then the net force, the net result of the different forces is what causes an acceleration.
Ta tanda di kapsa nga sugu shuchiki sindasha jagu yorwa di kapsa ni shuks di kapsa shuti kawala kugu yoresa na keti nyubo chiki gangla ya shu mampu chu pogo yobai na shu te takit na chondong ku shu sigarwa ta zanglak ku shu zangshu chi yorwa o di la ya kugu yoresa ta di zanglak shu te tang ya na zangshu di la tani tete nyubo di la ya na ko nyuno chi chepa chi garwa di che zang tanda di kapsa shu saya di nyubo chi gangla ya shu mampu chu pogo yobai na zanglak ku shu di la kugu yoresa.
So that's what I just said. And the acceleration is always in the same direction as the force. And finally, the effect of the mass. So for the same force applied to different masses, the bigger mass has the smaller acceleration.
Ta keting asuge shu che chingpa chingyubo mando ngaja pai baina ani ditse chibi girwa ditse chibi gyubo telaya ane nyunon chwa yores.
So specifically, the acceleration is equal to the force per unit mass of the object.
Tan tanda de kap singi gwati ka nyunon ta nyunon ka su chi thegre se ati ngasuge ani ditse zishireri gangla popi shiki chichon chiwarwa te ta chongyores.
I haven't mentioned units very much, but if we wanted to do calculations, the force is measured normally in units called newtons, and the acceleration given a force in so many newtons, you would calculate it as that many newtons divided by the mass in kilograms of the object.
Ta tanda ngatsugi tegi zishi rang kolaya shuchi de shijayo mare swa chizang tanda ngatsugi ta zishi rang la ta ba imbana shuk se ti ngatsu zishi newton se ge zishi tina chenjare stin tabalaya ani nyunon se ti ge zishi ti kangi tan songgo yore sena ne duse te ta namji kilogram na chejagarwa kilogram re la ya newton ka chuchi pogo yo ba zishi tina jinali kores.
Yeah, a force of 1 Newton is actually very small. It would be the force of gravity on something that is about 100 grams. That would be 1 Newton.
Tanda nga so shutse Newton chi yemba bana ro shutse Newton chi se te ha chong chong re so tata nga su pisha sha ba bana ngübo ge dechela ya gram jayo pi ngübo chi gang la ya sikola ge tenshu popi ge tenshu tang ne halam chongres.
Mhm. Okay, so that's essentially Newton's second law. Actually, yeah, all four of these things are Newton's second law.
Ta danda nga su ngoto chi ju te ta kala na Newton ge tam chi ni pa ko la res.
So there are two more of Newton's laws. And yeah, go ahead.
Newton ge tam chim shenda ni yo res.
So let's go back now to Newton's first law. And you might ask, well, you probably heard of Newton's first law. Newton's first law is usually told in the following way. It says that if you have an object on which you know there is no net force, then that object will, if it was stationary, if it was standing still, it will continue to stand still. And if it was moving in a certain direction with a certain speed, it will continue to move in that direction with the same speed. In other words, if there's an object that has no net force applied to it, its velocity remains the same. It has no acceleration. That's Newton's first law.
Ta Newton ge tan chin tangpo te la ya deshe jabe kapsa Newton ge tan chin tangpo te kana deshe jayo re sena ane ke te ro ngebo chi ke gang la ya ane ko changlak shu te laikor chi phope yo pa ina changlak shu pho te ge ta chondom gi disgura chang shu te laikor im ba ina ane ngebo te ko guchu mepi gi nevala yo pa ina mit tung guchu mepi gi nevala dekre ne guchu tang yo pa im ba ina ko ge nyutse Taranja gala metute guchu tang dekre yes gores wa tan de chi gente she pa im ba ina ane ngyopo chi ka gang la ya changla shu te lekor chi pho pa im ba ina ke te shu chi pho me pa im ba ina ane ko ge nyutsela njro mes gores wa changla shu chi pho me ba ina ane nyutsela njro mes ko le nyunon tek mes res.
Okay, so if we think about this a bit, this doesn't sound right. First of all, Newton's first law sounds like a trivial consequence of Newton's second law.
Ta tanda de kapsa nga su do samli chitang ba na Newton ge tension ni pa te ani kar su da Newton ge tension tang po te Newton ge tension ni pa li chong an ro chi dos.
Because remember, Newton's second law says if you have a net force, then you have an acceleration in the same direction as the force. And now Newton's first law seems to be saying if you have zero net force, then you have zero acceleration, which should be obvious from Newton's second law.
Ta da nga su Newton ge tension ni pa la ta ba na nyu po chi ga gang la ya sang shu chi thai ba na de la nyon ching jong re so nyon jong ya te ani kange de chong go re se na ko nyon jong ya te ani ka su re shu ku kha sho la nyon jong go yo se go re ta Newton ge tension tang po la ta ba na Newton ge tension tang po ka se go re se na ko la ya sang shu chu ma the na nyon thek me se go re ta din stam ba la ya ani Newton ge tension tang po te Newton ge tension ni ba le ta ko rangjin ta chong wa chi im ba res.
And the second problem with Newton's first law would seem to be, why is it the first law? Why does it come before Newton's second law?
Da so samle jenda chi tang ko te ka re se na Newton ge tension tang po te Newton tension ni ba ga ngon le bu no go jun sen ka re se de sam tang go yo res.
Okay, so let's clear this up. Let's clear up the problem. The problem is Newton's first law is more subtle and more profound than it sounds.
Ta tanda ge nga su samle tang bai bai na ya ko Newton ge ten tang po te ko ge ta chi kanda do chi na ya du se chi ro ta ta nga su ge chi no ya ta ko te le ne ko chi kar su re non ton den ba ta ani ting sa ba yo res.
So the key here is that in Newton's second law, when we talk about a force, that force is always due to an interaction with another object.
Ta tanda de ga Newton ge tan tin yi ba ka sang nga su ge shu she pi yo res. Shu she pi ka se shu de ka re se na ne ngi bo ni ge pa ro la ya ani de wa chung a tan de thu chung a ro wa ngi bo ni ge pa ro ge de jo la tan ni chung yo res.
So I'm going to do another of my little moving illustrations here. Let me show you an example of where you can have an object accelerating without any interaction with anything else.
Ta tanda de ka sang nga su ka re ta ge se na ngi bo chi la ya nyun non jong ba ka shi la ya shen da ta kar su re ta de jo me pa interaction su ro de jo me pa je da ma thi be ga ne du yo pa ge ne ta chi de la tang gi is.
Okay, so here we go. So the situation is this: there's a train, or a wagon in a train, and there's a red ball on the floor, and the red ball is near the front of the train. The front of the train is to the right here.
Ta tanda de ka sang nga su ge de la ta gi is ro pi chen de ka re se na tan de min khor ge ne ko khang pas go ta khang gam chi ba che ro ne ti na la ya polo mar po chi yo res polo mar po te ane min khor ge ane ko den sho sa la yo res tanda de ka sang nga su ge e sho te du yin bi cha sha gi is.
Right, and this is important. You are sitting inside the train.
Ta tanda de ke chen bu cha ge is tan chorang in ba na min khor ge nang la chok de res.
All the windows are shut. You can't see outside. The ride is very smooth. You don't feel anything.
Ta tanda de ka se ane min khor ge ge khong ka za jap che yo res ro ane cholo chi ga thang go yo ma res. Tem se ane min khor ge dua te pe te tan jambu shu chi du yo re chorang kar su ber tan gu chu tang go yo me khor chort ma res.
And then something strange happens, and this is what happens.
Na ta de je la ya ken sa bo chi chong res ta ken sa bo te tan de chong res.
That's what happens. The ball, for no reason, rolls back to the back of the train. It accelerates to the back of the train because remember the ball was stationary to begin with, and then it accelerates towards the back, right?
Ta de la ken se kar chong res na polo te ko tambo dan gu chu tang go yo ma ro gu chu tang me pi ge ne ane tanda ge ta min khor ge jap cho la ya ane ko gu chu tang ba res gu chu tang sa bla nyun thep chi to ba res kar chla ba na nyun the se ka se tambo gu chu tang go yo ma ro tene ko gu chu tang sa ba la ku le nyun yo ro.
Let me show that to you again. This is for no reason at all. This is what the ball does.
Da jun chen chi ja me pi gu ni se ro da ta mi ti nang lo la de yo ro te ka se jun chen chi me pi gu ne sam chi la polo te ge dina ro chi che ba res.
Okay, so what's going on here?
To te ka res na tanda de la ya ni ka de la ya kari jong yo res.
So let me show you the same situation now, but from a different point of view.
Kari chung yo res ro da to te res ta tanda ngi che chu la 단대기 가서 그래 니 땅때 란자제 인바는 가지고 뒤시 만다와 칩니다 다사 만다와 칩니다 그 옆에 놓스디 단다 땡기인스
Okay, so here's the train again. The wagon is transparent, so you can see what's going on inside. But now you are no longer inside the train, you are outside standing on the ground.
다 단다 되게 갑질라 가레스나 가지고 민크로가 감티 아니 고 치세나세 바다 시그 주지로제 아니 저랑 민크로가 나라요 말이스 저랑 민크로가 칠록라요 레스
There's a tree there that is going to be stationary, so the tree doesn't move, and you don't move either. You and the tree are not moving, and the tree there is just for reference.
Are you going to show your screen or?
Oh, sorry, I forgot. Sorry about that. I forgot to click share.
네게 잡로라야 그 그냥 신도지 샤이스다 신도된 가수가 지금 뒤시로 그 찹들어와 인스타 리캅스 신도들랑 그쳤던 거요 말이 아니 저랑형 그쳤던 거요 말이스.
Okay, so yeah, so there's the tree and there's the wagon, and you're standing outside. This is important. Okay, so watch what the ball does. And for reference, look at the tree at the same time.
Polo te ta ane te la ya tang jalok shindon te la ya te de paina polo te ge yang ko nesa la ya jero kana do chindu yo me choro wa hotel la ya ane taro cheese.
Okay, let me show that to you again.
Yeah, such thing is.
So initially, the train is not moving. The ball is inside the train. It's not moving either. And then the train starts to move, but the ball does not move from your point of view. Because if you look at the ball and you look at the tree, they both look exactly the same. It's just the train that is moving. Here we go.
아니 담보디 가서다 토마테스 그러다 민콜고 골감디 토 담보는 거죠 담비 값을 아니 민콜탄 거죠 당신 누구다 가수기 철롱이 답이게 다츠고는 답바인바나로 왔다던 거네다 뒤서든 가수니 따고로 바타서티로 스타바인바이나 민콜팅 거죠 당바레스로 민콜티 거죠 담비 값을 폴로티 토 담보라로 거죠 등군 접이 값을 폴로팅 거죠 당거 말레스 되게 제라야 아니 멘코트 잠든 게 좋다는 거です. 가수들이 다야티 카레스나 뒤서 된적 계시고요. 단단 가수 뒤서데 잡로라연 구메인 비 신동텔라테데 되시고요.
One final time.
양지스 땡긴스.
Okay. So the question is, and this is something that we don't necessarily think about, is how could we tell that something is moving?
대가 속에 가서 남진 바나스 삼로 대가들이 시 땅거 말이 심바이나야 저한테까지는 가속에 니부친 그저 땅거도 세치고로 니부친 그저 땅거도 세팅 가속 간다스 랍 그레스
The only way we can tell is if we can compare what it's doing with other things in our environment that are not moving.
상가송 유부친 그저 땅거도 세게 개체티 같으시 그래서나 나주가 거기라야 요쪽이 그저 땅거 매비기 유부지라야 되되데 아니 유부신다 진 그저 땅거도 세데 가수시 그래서
We have a specific name for the set of other things in our environment that are not moving that we use to compare motion with. We call that a reference frame.
nga suge karsa greta miupo ching guchu tang do mendu se te ne nga su khoi la yo pi ge ta ching gume ge po tang tena da uchi shi sha de ta ne de shi jang go re ta shi sha sa ge te la ya nga suge tu shi se gres.
Of course, not moving means not moving relative to us. In the case of the train, for example, and if I'm sitting inside the train is not moving relative to me, but me and the train were both moving relative to the ground.
Ta dan da de kap se yang ko guchu tang je me pi ge nyu pu chi la teni se ke chen de shang stam bala ya guchu tang shi me ba ge nyu pu se ge chete yang ko de sa tun jo chi chi re sro pi cha sha ba na ke te nga min khor na la ya de yo pai ba na min khor na la de yo pai ba na min khor nga la te bi ge min khor ting guchu tang ge yo ma re sro ka chi la pai na ta ko patlan jor du yo ma ro ko yo pa ta de ko ro yi mai na yas 세실라 티비와 살라 티비 나타 민코 니션 구초 당고요 레스 디스탐블라 데 갑스 고메기 니보사데 키시샤마 삼발라야 티사 튠조케 티사 튠조 칠라텐데 탐 디시자람 고레스.
Now, if I'm in a reference frame that is accelerating, however, then I'm going to see strange effects.
Ta ke te ngarante nyuno chi shimbe ge tishi chila yo pa imbaina ani nge chi karsugreta nansina dikore tinda shuchin tinda ken sapo tinda thongores.
I'm going to see objects like that red ball accelerate for no apparent reason.
Picha shaba imbaina tanda ko karsugre ta minkona ne tampo te ge kapsi imbaina junsen cheo me pi ge gune ya polutela ya nyunon jombe ge ne tantra do thongres.
So and this may be an experience that is familiar to you. If you ride in a train, the train you get on the train is standing still at the station, and then you get on the train and the train starts to accelerate forward, and you feel in your body, you feel that you're being pushed backwards. In fact, if you're not holding on to something, you might even fall.
Tatanda picha shabana chichu minkona la de pikasro minko ta tangpo minkona zui kapsa ta minkor de ko babsila ya ta de yorwa tene minkona zunu chela ya minkor de guya gutsu pai baina chorong ge zupuna chwa kare chiore sena chorong chi jablo la thenye do gorwa minkor den danlo la ya nyuno che chin rugi kapsa chorong zupu gan la ya chi jablo la thenye ge chwa do le gres and sam la ya chi la pa gen jusa do tere do la chi manjina ne jablo la ya red do ge nya kan yores.
But there is no force acting on you in the sense that a force is an interaction with something else.
Ta tanda de kapse chorange zupo gangla choranga gangla ya shuchu pukuyores wa shuchu pukuyores ta shute nga soge nyupo shenda chi tang ane deju chi bi kapse wa chongo yopa chi la ya kwalangures.
There's no giant magnet back there somewhere pulling you back.
Ta de kapse yang chi nga soge ngarchak taw yorwa de kapsa tu khalmi yo khablin taw chenbu chi chu jalona tani de chu tina no yo mares.
Now, soon after leaving the station, the train doesn't accelerate anymore, and now it's going at a steady velocity.
Can you repeat that again? Some of the word cut off.
So the after leaving the station, after a while, the train does not accelerate anymore, and so now you're moving with a steady velocity.
Ta ko minkorte ko karsugureta gucho konsam chitano go jela ya kula ya nyino me pache ane minkorte ge joksete yang ko nyursete yang tembu kone gucho dujigres.
And for for simplicity, let's say the train is not turning in any direction; it's going in a straight line, so the velocity is constant.
Hata tanda de kapsanga suge de kapsanga su kwalen de kar kwalangi sena ane ti kapte la minkorte nyutse tembo kone dujigure sa de kapsim baina kun danola ya khatu tan rugo pa matone ko pasla ikuyo patang chigram ka chochon rugo patana dola ya samtang mes.
And then you can get up, you can walk about, no problem. You don't feel any strange accelerations.
Hanta de kapsim bana chu ya lanch ya man chinchi tu ste baina ya ko tab de gone dut kres te kabla ya ngaso ge ya nyno cancel de na do ngaso su poga tele chorgumares.
But then the train approaches the next station and it has to slow down. So once again, there is an acceleration. The train accelerates backwards this time.
Tatanda de kapsim baina roa kete ya tachu minkur gambapsi jema tela ya ane lebi kapse minkur te chita tangrwa chita tons tambala ya yang kola nyno chitapio resta tanda de kapse nyno ti karire sena nyno ti ane minkur ga jabu shola chitapio res.
And then the same thing happens, but this time you feel that you're being pushed forward as the train slows down. So again, you have to hang on to something not to fall.
Tanda de kapsim baina choron la so kari legre sena choron chi dano la ya bijak tang ya do so do legre ro minkur te chita ru kapse ta de kapsim baina choron ga ya chi ya man jusa chilan juna ma shi ya chi karsere do ya ge netante de chongres.
When I ride the train, I like to see if I can stand still without hanging on to something, just to practice my balance.
Ngana minkula de kapsim baina chi ya ma la pachiga ma chang de de ane ko ya khatu lang dki tkuyo metela chata chi yes jinse zo de ngarang ge chi jitsa tumnyin chi ya ti kola ya jongden chi ya chi de yes.
Yeah, so when your reference frame, because the train is my reference frame, when your reference frame is not accelerating, everything feels as if you're not moving at all. You don't feel any other strange accelerations.
That and the capsiro nga su tuishi ting gushu tang me tuishi te la ya nyon tek me baina ninga su ge karsugure ta che serwi cancer ge data tne ro thong ma res ta picha sha baina ta chorong ge tuishi te minkor imbi wan ta na minkor te la ya nyon tek me baina ane te la ya chi namjin ta mandawa ge sura cancer ge data tne ane chorgma res.
You can take a soccer ball inside the train and you can kick it. You can apply a force forward to the soccer ball, and the soccer ball will accelerate exactly as Newton's second law says relative to the train.
That minkor na ne chorong ge concept polo chi ki son de ta tela donja shan do ta ya do ta tne do chi je baina ta ti na ne ko polo dalo do ta ja bo twa ta chi ro ti ge ne ta te ane Newton ge ten tu ni pa ge desi ja pa na ji chima chijin jong res.
You can do anything you want involving forces, and they will behave exactly as Newton's second law says, while the train is moving at a steady velocity.
Ta tanda de kapse shayat kala na minkor te nyurse tembu chike gala duwi kapse so nyurse la joan do me parwa nyurse tembu chike duwi kapse ane chorong geta namjin chia ge khari chi che bai na ya shutang dewa yo chugarwa shutang dewa yo chi che ko khari chi che bai na ya Newton ge ten ti ni pa ge desi ja ba na shin jong res.
But when the train is accelerating, either when it's leaving the station or when it's slowing down, approaching the next station, during that time, there will be an additional acceleration on everything inside the train that is not caused by a force.
That you said that is not caused by a force.
That is not caused by force. So things will accept while the train itself is accelerating.
Okay.
Anything inside the train will have an acceleration in the opposite direction that is not caused by force.
That under the capsim bannerwa, tangiting as soon you set and would do a capsicum in the Jabarwa. That under Natsuge Minkorte Minkorte Roa, Tanda and Minkorte Tampu Guchutan Gutsubatan Jelaya and Babsi General Stambalaya, Chitala Drubi capsim by Narwa, Chitala Drubi caps and Neton Telaya, Tigi Cap Telaya. The Minkona Yopi Nibo Sama Ganlaya and Yunonchi Tepkioris, Ra, Yunonchi Tepkioris, Yunosota Shuchi Tepkioris, Ra, Yunochi Tepkioris, then Yunochi Tepati and Yunoti, Shuchi Cheva Maris.
So what Newton is saying to us is the following. He's saying, look, before we get to the second law, let's make sure that any forces that are acting are true interaction forces.
So Newton Carisagores and Agatsuta Newton attempting Yibag Malhe Gungalaya and a Shuchi Pokuye Sagi Kechetion Stambalaya, Shuti Ningasu Yupu Nisgortang Yupu Jejola Teni Tepig Shuchi Yimba, Ning Yochi Gugures, the Deshijayoris.
And that any acceleration that we observe in an object is due to a real force.
Hantangasung Yubuna like a Tepig in Yununde, and a shoe mumachila Teni Joimba, it is.
So we need to make sure that our reference frame, everything that we use in our surroundings to compare motion to, that our reference frame itself is not accelerating.
That take up some association that Chikarita Guyores and Natsugi Tachi Nubuchin Guchutango Yobate Torsatan Tenado Tishi or what Tishi to set in Joke Nede Telaya, Nunchi Mepachilaya, a Tampone Guyores.
And just to be clear, we don't have any information about anything outside of the reference frame.
Can you repeat that again? Some of the word cut off.
So again, we have no information about what's going on outside our reference frame. We can't compare our reference frame to anything outside.
That another thing, Minkonona, the picture, Taula picture Shapana, Natsugi, Karsatam, Chalolaya, Kari, Chungu, Yumeg, and Netante Hakumaris, Karchila Bana, Natsugi, Chaloka, Tishichila, the Tangatsugi, Netante, Dursayo Maris.
So the first law is the answer to this question. How can we tell that our reference frame is not accelerating?
That Tandagi, that Newtongi, Tentum Tampoti, and a Kukari Deshijagores, and a Keti Tampoti Kari Deshijagores, and a Natsuki Tuishiting. And in Yunoji Mepag and Nitante, Kandas Deshijat Grace at Deshijagores.
So Newton says there's a test that we can do.
Newton de la Yati Haku Chetung as a Taxichi Debiagres.
Look at an object in your reference frame that you know has no net force acting.
That Chorungi Tishinala Yoping Yupo Chigala, Yupote Galaya, and issue Jian Pokome Baina.
It could be, let's say, a red ball sitting still on the floor.
Tati any Carsananga Shela Gala Yopigi, Huluma Puchi Banan degrees.
And watch what it does. If it is not accelerating itself, if it does not have an acceleration, then you know that your reference frame is not accelerating.
Ta ti polo te roa tus YouTube polo te ani nyunon chi me paina polo te la nyunon te me pain baina chorong ka kari shet kare sena chorong ke tishi jigoro chorong yosa ke tishi te ani nyunon chi me pa roa nyunon chi me pares le tin de shi jat ko res.
In that case, any acceleration that you observe within your own reference frame, you know, is due to an actual force, an actual interaction with something else, and it follows Newton's second law.
Ta tanda ki tinda do ge ne ta tinda do ge tishi ge kapsa ani ta chorong ge tishi no la jong ya ge da ko nyunon chi bai bai na nyunon chang ma te ani kar so re ta ngibo ge treju la te ni jong we ge shu ngune chi la ten ba te ani chorong ge shet kres.
So now Newton's first law makes sense. It makes sense that it comes before Newton's second law, because it's a test to see whether Newton's second law applies in your reference frame.
Ta tin stambala ya Newton ge temchin tampo te temchin ni ba ge ngela yong nu ge jinsen te khase u cha ge yore sta Newton ge temchin tampo te ngela yong ba ge jinsen te ge khari de shi ja go re sena ani Newton ge temchin ni ba de ni chorong yosa ge tu shi te ge nang la ya pecho tanga yo me se ya ge te ani takshe chi de te kuchon ku yore.
So at this point, what I would like to do is, before I go on to talk about anything else, what we've been discussing here, Newton's first law, I know is quite complicated, and I'd like to pause and allow for a little discussion at this point. If you have any questions about any of this, I'd like to hear them. Or let's see, first of all, if you have any questions about it.
Da da dir ma da mu ma thu nge la ya Newton ge tentin tampo te ge chi ko lan tan te tes nyong jing ra chi yo res tin sta bala ya ni che chu na ne ti ko la ya chi ya sam su song da ta ha ba de jwa jia do yo ba na ni jwa jia ge ku ka jia ins.
당기디 맹코는 거 모두 잡로 안 조지 건다 잡로 안 조지 나고 두질라 때때다 실로고 두질라 때때 랑산나 데데라
Re
anga chung yeunde chundoina ko okoti shala tundodi 모두 꼬라지 적으러 하고 가라 언제 도도지 되고 말아 꼬라지 적으라 다고 실로가 마송이나 실로고 향동 왔더니 로맨나 있나요 그 꼬라지 적어라
re
다 식지가 대표와 말라서 식지 대표인데 말해야지
shu take do se jinsan te kora ja bala tere la
맹코르디 샬라코 라가다르네 다르치고 꼬라지 걸어와서 꼬라지 참좀디 꼬라지 잡네 고 실로암 조자간도 지거라
re tati tayati shilong ni tagyo ro. Yeah, one in the example about the trend and the red ball from outside reference, and we see that usually in real experience, when we see ball, just in that case, it looks like it's staying stationary. But when we think about a ball on the ground, usually when it goes back to the back of the train, it usually rolls because of the friction of from the ground. So
sure,
there is a kind of force.
and I apologize. My skills at building an animation are not that. So I didn't draw the ball so that it was rolling. But you're right. The ball is not sliding; it's rolling. Yeah. The whole point of having a ball in the example is that there is no sliding friction, so it's absolutely free to do what it wants. Yeah. But you're right. It is rolling.
那当然这个是这几个是给那个当然对那这里等下的到马图巴马多贝当然我就是弄的大白白呢ko polo de ne ko dalon ni jablo dra choro是弄的大个是呢当然是的ko polo de je da ka bari te chi du yo res ko shaja khong ku to me ba shaja de bari te chi du yo res imba na tanda nga su de la ya shela tanga chi polo ge ne tang de she jang stam bala ya di ka se ta ka so ta shela tang polo ge ngwe ni she ka su jam jam yo ya che di ka se ne ko nga su ge da shi yo ro da go shi da shi chi yo ro 어디 가서 뇽뇽 다 하죠 뇽뇽 임베게 합시티 땅 요레스 이제 덴바리 단단가 속에 데모데 답이 값고 바디테 드주게 나바데 통금도 같이 좀 다스탄발라야 바디테 그 요레스
게타시 얘는 게타시인데
양치지.
양겨지
니 다스마 맹코르 때른 좋아 당 저런 조디가라 년노직 탭기 어레시. 년노 태워야 나요. 데라 식인데요 말해지 지셔서
아하
말해지. 근데 오고니 다다스마 좀 땅보 온라시 좀 선실에 온디가라 제주르게 식지 요르라서 다단기 땅보 식되면야지 지난 제주르게 식지 요르레시 다디 식된 제주르게 식된 인사라 년노 태워야 돼. 그때 서우 참았어.
he's confused because when you have mentioned about the first law you have mentioned about the initial starting point you feel a force initial starting point when the train start moving you feel a push and when it stops at the next station you feel like at the beginning pulling and then at the stopping station you feel like pushing or something like that and during that time you said that it's not due to a force and then when you talk about how the first law is attached for the second law applies, you have mentioned about interactions.
Okay.
A force due to interactions. So I'm a bit confused with the no force in the first case, the acceleration or like during that time acceleration and the deceleration, you have push and pull, but you said that is not due to force. But then you have mentioned about force that is due to interactions. So a bit confused with that.
Yeah. Okay. No, that's great. That's why I'm looking for these questions. So there are several questions in there. Let me try and answer each one. So the first question, well, no, actually, let me go back. The bottom line here is an acceleration. An acceleration is simply a change in velocity, change in motion. An acceleration may or may not be due to a force. I'll let you translate that.
단다 값이 지 단다 좋아들어야 자신만 붙이도 스타트에 나네로 좋아 에티나니 시티가 속에 응유과시가래서나 자식 응유과시가래서나 뉴런치요 바이나 뉴런티 지치나 야 슈크셰 바레 지치나 슈는 거 슈크 마셰 바데나 용그레스
A force is an actual interaction between two things. For example, the force of gravity. The Earth pulls on the moon and the moon pulls on the Earth. that is the force of gravity. Or if I drop something, the earth pulls on whatever I'm dropping. That's the force of gravity. It's always an interaction between two things: the ball and the earth, or the earth and the moon. It's always an interaction. That is a force.
That shoot seven cups in by na cutting by na young Tandadi cups shoot the cutting by na you put Nigi Parogi, Dejula Tenichungu. Is the pitcher Shapina, Sukulagi, Dawati Matembatan, Dawagi Sukula Yatingi Patan, Yanagi Puluchi you pine by na Pulu de Sukulagi Matangerwa, or this Tambalaya Katu in by Nayan, you put Nigi Parogi, Dejula Tenichungu. Is the Dickerson you put in by na Sukulata Dawata, Skulatan Pulu Parogita, a Dejula Tenichungu. Is shoot.
If I kick a ball, I'm applying the force of the ball. That is an interaction between two things, me and the ball.
That Dandangi get the Puluchilla Donja Shiba by na, and a Polo de Pandruris, Ni Kampa Polo de Gashuch Tegores, this Tabalangi Kampa the Polo Niparola, Deju Chichungores.
That's what we mean by force. So a force is always associated with an interaction between two things.
That under the Bana Shure, shooting a team by nine, you when you parogi, Deju Latangures.
And forces, according to Newton, always come in pairs. So the earth pulls on the moon and the moon pulls on the earth.
That neutron gay Tatsuta by na shoe said the cutting by a cha this Pisha by na Sukulagi Dawati Matangi Retinashan Dawagi Skulati Atangi this.
In fact, that is essentially Newton's third law that we'll talk about a little bit later.
That I think as Newton tension some budget and then as Jela and the Shijagins.
So going back to accelerations, we always observe an acceleration relative to whatever our reference frame is.
That you know, said the Yansing as Taba, you know, take a tampo per ten, you know, you're saying Jorwa. That you know, said as to Katim by Nayan, you know, Nancy Tondegres, you know, the Nancy Candestongres and Natsuge, Tuishi la Shisha de Tuishi can give email a Shisha de you know, Chikatina Tongres.
So we know that because of Newton's second law, that forces and accelerations are very, very closely connected.
Newton attention Yipat Shisha by na shoot on you know Nisha, Nikunin draw Tamsayoris.
But there's an exception.
You know, Yantella Yanko person, the mind be charging you this.
The exception is if your reference frame is accelerating, then instead you will see that objects relative to your reference frame appear to be accelerating in the opposite direction, even though there is no force acting on them.
That under the capture, that Musegi Yanko Tita Mindbagi Chachi or Tekares and a Katie Choranga Tuishikru and Yunonchi Yopaina, so Tuishikru and Yunonchi Yopaina, Tuishi Tenala Yoping Yubolaya, Kunyonchi Tekures, then Yunonti Shuchi Latanichon Mares.
So yeah, your train accelerates forward, but if you're in the train, that is your reference frame, then what you see instead is that the ball rolls backwards.
Get the chura Minkonana Yobache, Minkonana Yona Chorangita, Tuishi, Minkol Nantilwa, this Tambala Minkola Yunochin, the Lord Restabala, Chorangotomatic Tungresna, Pulu in the Lonemanco Barete Javoyong, but the Tungures.
So these accelerations, in this case, the acceleration of the ball is only relative to your reference frame, and it's not caused by force. We have to have a way of testing whether this is happening to make sure that we're not including in Newton's second law forces that don't really exist.
다 단단히 값고 다 볼로틴 들로네만 그래 자볼라야 바리 탑이 용거와 데카레 시스템발라야 저런 게 뒤시라 시샤바이나 저런 거 뒤시 그런 거 줬던 거요와 구쳤던 거다 뉴는 태고요와 뉴는 태발라 텐데디 네 볼로티 자로라 바리 태기 위해서 네 값이 인바네 쿠강라야 슈추 포메바 와 데레스타 팀바나 가수기 디페셔당 데데 뉴트론 기 텐팅 니파게 나라 아니 코 가서 그래다 가수기 뒤시데 아니 구메임비기 뒤시데 임발라야 고 똑같이 치도 비슷한 거랬어. And can you say that the Newton's second law only applies in non-accelerating frame of reference?
Yeah, that's exactly right. Newton's second law applies in a reference frame that is not accelerating.
다 단단히 값으로 왔고 다 다마티 쉐바인 바나가서 다 뉴트론 그 텐션 니바 치고라 뉴트론 그 텐션 니바 데이터 가서 슈티 뉴넌데 디셀레저스 거라 뉴트론 그 텐션 니바데 니 가라 페셔탕아요레 시스템 발라야 아니 뉴넌 지지 메피기 디시치크나네 페셔탕아요레 스와 뉴넌 지지 메피기 디지털 페이지다요레스 나 뉴는 지심비게 디지털에 페이지도 선도 말레스
I wonder if he thinks that makes a little bit more sense now.
Yeah. Shemba, any other question? Tangi tashi segundo sanchi. 고금에도
고데기
다 그거도
어디 다기 간저 아니 릴리기 단다디 다금 가서 강감지라 디 나말라 담보 고데 마두 시네마 리도자 다디 난시지기 단다 간저 페나 하밍 버드요 차 하밍 버터지 딘데 강감디 나말라 샤니 단다 아니 도시네 푸르데나 바낭갈라 두스 푸르데나 아니 디 강감디 두시네마 로 고주데 잠바 타가 하밍 버드 타가라 피게 파 캡초기 딜마 탑도르에세 orta ingyu karesana ngigala nyunenda shukde sangma chikba chikya dojira ine ya dile chadi ya tagara dosine pa sikhala this dabdoreese.
So his question is the similar that a train and car, but instead of a ball, if you have a hummingbird floating in the air, and with the same logic that we use for the ball, it will just hit on the back wall when the train accelerate.
Oh, I thought I heard the word hummingbird. I thought maybe
yes, hummingbird. Yes, hummingbird.
This is something else, but it was an actual hummingbird.
Yeah.
What a lovely example. I love that. The hummingbird inside the train. Yeah, again, that's a very good question. The hummingbird will, and a great example because hummingbird does actually hover, right? Which not all birds do. The hummingbird is able to hover by pushing against the air in the train or the car. So you have to think about what is the air doing? What is the air doing inside the train, the car? And the air is moving along with the train or the car. So the hummingbird would, if the train is not accelerating, the hummingbird would do what it normally does with no problem. I'm guessing that if the train is accelerating, then yes, the hummingbird would be pulled to the back or to the front, depending on the direction.
단다게 조아티페 야고도 스탄다 hummingbird 그러다 주 천천히 걸어 되게 조아티페 야고도 삼로 야고 당샤스다 단다디 값서 아니 단다 ngasoge 지오디로와 고 야라 남칼라야 풀다 딩다비 값이 마이나 고 지야티 고게 쇼파 W를 쇼파 W라테니 아니 올라요 피가 롱 라테니 던 코양 코레다 ngaso 롱 라테니 때 쿠파나나 풀트고 요와 딩데트 고 요와 단다디 값이 게티 아니 게티로와 다 민코르기 감텔라야 아니 가스그래 뉴런 테크 매바인바네 남진 그런 것까지 지금 요반하신 지대 그래스게 정구마레스 딱 뉴런 테바인바이나 네 단다 저런 거 삼바나신 그 가스그래다 그 영만나 잡로라만 거다부터 영만 돈올라야 루아치거로 니 tonten 정그레스.
It's difficult to predict what would happen exactly because the bird would react to any acceleration. Maybe it would beat its wings more in one direction. So it's hard to predict exactly what would happen, but I'm guessing that the bird would the acceleration would be too much for the bird.
단다 임바나 실게 임바나 아니 단다 딱갈수 그래. 다 치오인자로 치오인 담발라야 고게 다 지금 담라야 년년로 치태바 임바나 고 네사들레 년년로 치태바 임바나 때라 고게 람사 야렌치 테그레스와 야렌치 테데데 아니 때레 도비 졸라야 갈수 그래다 지금 쇼파 유지 고 당념주에 답시 당하지 걸어 왔는데 너 지금 지에지그레스 임바나 단단디니 갑라야 아니 연년 수천부지 존스탄발라야 아니 때라야 고게 갈수 그래. 다 야렌 족보스고로 수천부 때마 그바지 아니 고 지금 잡로라야 드야로 당 아니 카페 값은 dollar 두야 치고로 어때 니 tonten 정글 상기스.
I think Chad is doing the experiment there. Yeah. Could you do that again, Chad?
I can spotlight him first.
동무대 괜찮 이게 지금 동무대
There we go. Yeah.
Tandenge
Exactly.
jiwa de karsana gege dege nganzo ngobo ji draw mando sege tishi de ngobo tishi de nguje ja meba chile shisha goran tinida ko sange ta da yana mena nganzo de yana nganzo nomdun deni pha draw de pigene deni chuyonge de la de nganzo nomdu de pha draw ya ba hakungda pena deni pha draw yana phashe ni chuyong go ya ba nomdu jana ani de lo de so draw ya ba hakungda phashe ge tishi deni chuyonge de khonguje ja gora 어디 네 뒤시 샤드 두고야나 만나서 데니 추용해데 아니 니바딜레 페나 간조 넘리니가 디녀도 파 드로나 파슈기 넘르데 페나 간조 가만 디니 냠뉴지 중사 간조 넘르도 디사네 바노베데 tumba 뜨장제 템바 추니 메바제 아니 넘르 간노르 디니 네 넘르 디니 파 드고야레 파슈니 넘르지 다랑 파 드고든 데니 파 드고더라 파슈 넘르도 드고 지 초금이도 디카레나스 파슈 nombre drogo ba chune tsugumud phage bano tumbana dedesha ranja
and my question I have like two part from my question. The first one is if what I felt is what I thought is you have mentioned that we to tell something for our reference frame to say something is moving or not, something is accelerating or not. You have mentioned that we need to take a reference frame that is not that is stationary. And for instance, like in my experience, when I was flying, and we saw another plane is coming like in the opposite direction. And with that as a reference frame, I see that my planet is moving when there's no clouds in the sky. So can we take a moving or accelerating object as a reference frame to tell something else is moving. For instance, in that case, reference frame as the other plane, and with using that as a reference frame, I can tell my plane is moving. And also in that's the first part, and the second part is, and another instance, in a clear sky, my plane is moving in the same direction as the other plane, another plane in the sky, and with that, I cannot tell that the plane is moving because this seems stationary.
Right. Yes. So okay. It's tricky because we're always trapped in a reference frame. Or Chad's doing another one of his experiments there. Yeah. Okay. Oh, well, we haven't talked about sideways accelerations yet, but we'll talk about that. Yeah. So, we can assume the worst case scenario is that we have no information about what's going on outside our reference frame. So if you're in a plane, you have to imagine maybe that you're flying at night, that all the windows are closed. And actually a plane is a very good example, because the plane, normally the flight is very smooth, so you can't really tell. The plane isn't shaking very much or anything like that. You can't really tell. And in a plane, this is particularly clear, that when the plane is flying straight and with the same velocity all the time, you can get up, you can get around, you can do anything you like, you can have your coffee, whatever. It's exactly the same as if you were standing still on the ground. Nothing is different. Galileo talked about this, and he used the example of a ship where you're in because there were no planes in the 1600s, so he was familiar with the ship. Yeah, okay, so I'll let you translate that, and then I'll carry on.
Tanda di kapsir wa nga su namtri te chitang ta pisum pe ya gores namtri imbai na chitang ko tan jokse tembu chiyo pi kapsi imbai na namtri ta namtri ya perchin jokse tembu chi ko lan du kapsi imbai na ta chorang gi na ne ta namjing gi garsu gre da gari chi gi yo pa nan shin chi de na de go res de la shuchin ro ta ge yo ma res ro ta di kapsir gari chung yo me te gari chung yo me te Galileo gi mama de si chi ja yo res pa tu chitum na ro to ku desi chija yores ta desi chija yore imbana ti kapsu namtu yomarwa imbana ku chutula ya pisha de tan desi chijon yores.
The other part was, if you're looking outside and look at the clouds, for example, or you're looking at another plane that is flying alongside, yes, you're always making comparisons, relative comparisons between one reference frame and another, really.
Dada di shenda di chorangi katu imbai na ya ngasu ge karsa ngasu ta katu imbai na tuishi chigla yoyza ne chorangi katu imbai na tuishi shenta dirchi de di ya namchung guchitang yo megi ne tanchi gorwa te deshe jang gores.
Yeah. If you're in a plane and the plane itself is accelerating, and again, this will happen at takeoff, and it will happen again at the end at landing, then that's why they ask you to put on your belt, because you could be thrown in any direction, and yeah, good luck drinking your coffee while the plane is landing.
namtrila ya nyunon thapi kapsimba na komando res nyunon thapi bana namtri ya pro tongmar bapi kapsimba na tila candidate ko ta karsa shuchin tegi yechang ne choron ta kuchagang de ta ane nga suge karsu da ta kara da uti changa churwa oti ti koge chabra ching da te chigi yores.
I just want to make sure of the time here. We are getting very close to 8:30.
Yeah, I
So
think we can go for break and then come back.
we can go for a break and come back, and we'll see if there are any more questions about this. And I think we'll probably also have a little time at the end to